Hey there, hi there, ho there. Welcome to Unit 3, Minerals and Rocks. Um, yeah, they are two different things. We'll get into that into this unit a little bit. Um, if minerals and rocks you really love, they're your jam. Is that what the kids say still? If they really raise your roof, is that what the kids say? Oh, yeah, I know what it is. If you think minerals and rocks are turnt, then Geology 101, we actually spent about a month talking about minerals and rocks. For this class, we will really kind of just do an introduction to all of it this week. And I mean, the information will come back throughout the semester, but we really only spend this unit on it, I should say. So yeah. So let's go. So let's talk about minerals and rocks. All right. So minerals and rocks are earth material. Let's talk about minerals first. So minerals, such as gold or diamonds and silver, or, anything fancy like that, has fascinated cultures and peoples for many thousands of years. And it goes back as far as some cultures thinking, certain minerals have mystical powers. Well, hell, even today, I know some people that are into healing and the different crystals and the vibrations and holistic healing, sort of those things. So even now, that idea continues. But as far as a scientific approach, minerals are the kind of the basic units of Earth material. In chemistry, they talk about, the atom as the basic unit that they kind of work from. Well, in geology, the mineral is kind of the basic unit that we work from. Next unit, we'll get a little bit into the chemistry of it. But yeah, the mineral is kind of the basic unit that makes up most, if not all, Earth's materials. There's over 3,500 different minerals that are known. One of my least favorite things in this world is when someone finds out I'm a geologist and they start bringing me all these minerals and like, what is this one? Man, I don't know. You know how many of these things there are? It takes a lot to. I mean, there are some very common minerals you can kind of start to pick out, but those are very few and far between. There's a lot of random minerals, 3,500 plus of them. So when people come to me and say, "What is this mineral?" That's my answer is, I don't know. There's a number of tests you can do to help you figure it out, narrow it down. Where did it come from? There's all sorts of things. But anyway, there's a lot of minerals. But only about 24 or so of them, 24, are common. Most of the other minerals and mineral resources are very uncommon and very rare. But minerals, besides, just the science of it, minerals do play a huge part in industrial societies like our own. So let me just show you kind of an image. These are some just different minerals. Again, some of these, I can pick out just with my eyeball. Some I might need to do a little bit more investigation. So amethyst we see here. I got some quartz, some rose quartz. Looks like pyrite. Maybe some sort of gypsum over here. Satin spar gypsum, that looks like. Not selenite. Selenite is actually different. Garnet over here. So there are some commonish minerals. You kind of see them and say, "Oh, it's that." But for the most part, there's a lot of them. Some are common, most are not. So anyway, but they're very pretty. You can see how people for thousands of years thought these were mystical and magical, and even now. I mean, don't get me wrong. I have a bunch of minerals on my shelves in my office, in my classroom, at home. They're pretty. They're great to look at. And these are the kind of the building blocks of geology, of earth materials. But again, a lot of times these minerals are useful. We use them in some ways. For instance, I don't know if it's on this image, but for instance, the mineral talc. You may have heard of talcum powder, but the mineral talc is a very soft mineral. It is used in a number of different things that we wouldn't necessarily think about. I mean, I don't even know how it's necessarily used in plastics, but there it is. I don't necessarily understand how talc is used in paper or in paints or in, hell, any of these really, but it is. All right. Remember, there's only two places stuff comes from. It's either grown, and if it's not grown, we mine it out of the ground. I touched that on that a little bit last unit, right? So everything that we have, no matter what it is, right? If it's not grown, it's mined out of the ground. And whatever we mine out of the ground, it might not be used directly. We might have to alter it and chemically combine it with other things. For instance, how to make plastics. But there's many uses. Everything we have is either grown or pulled out of the ground. So anyway, minerals, they're a particular thing. And in a later section, we'll talk much more about minerals, just focus on them. But minerals and rocks are different. So what the hell is a rock then? Well, a rock is a naturally formed, coherent aggregate of minerals. What does that mean? All right. It's a rock is a solid thing made up usually of two or more minerals. So you have a bunch of minerals. When you kind of combine two or more, that's what a rock is. Usually. There are some rocks that are just made of one mineral. But again, in general, a rock is naturally occurring. It's not man-made. It occurs in nature. And it occurs from the combination of two or more minerals, usually. Plus, there may be some other non-mineral matter in there, organic material like shells, which isn't considered a mineral. We'll define what a mineral is in a couple more sections. But in any case, that's how you kind of differentiate minerals and rocks. So here's a nice little image that kind of illustrates that. For instance, there's a type of rock called granite. And maybe you've seen countertops made of this. Maybe you've hiked in the White Tanks or in the Estrella Mountains. There's plenty of granite there. But typically in granite, it's a combination of a few different minerals, like quartz, like orthoclase and plagioclase, as well as muscovite and biotite. And when you can combine these together, that's what granite is made up of. You can see like the darker stuff is the biotite, kind of whiter stuff might be a particular type of feldspar or some of the quartz in here. So you combine these together, that's what granite is. Two or more minerals. It's also these same minerals that make up sedimentary rocks like sandstone, and it's also these same minerals that make up metamorphic rocks like gneiss. Also in this unit, we'll kind of define each of these different types of rocks: igneous, sedimentary, metamorphic rock. But I put this here not for that point, but the point that rocks are typically a combination of two or more minerals. All right. Again, later in this unit, we will break down each different type of rock. We'll have a different section for each of those. Igneous rocks like granite, scoria, pumice, and obsidian. Maybe you've heard of some of those. Sedimentary rocks like sandstone, limestone, shale, gypsum, and conglomerates. Or metamorphic rocks like marble, slate, quartzite, and gneiss. Rocks also have many uses, just like minerals. Rocks are, crushed up for cement, for roadbeds. For my front yard is full of rocks. All around campus, I look outside. There's a bunch of rocks everywhere. So it's not the coolest type of mining, but sometimes we just mine rocks out of the ground just for rocks. When people think of mining, they think of gold, and silver and diamonds. Well, yeah, that too, but all this other stuff's got to get here somehow. So yeah, some mines just take rocks. Yeah, that's about it. So anyway, rocks have a lot of usage. It's also decorative, monuments, tombstones, countertops, a number of things. So just an example. So not only the rocks that make up the structure, the rocks that are decorative, the cement made up of rock and sediment and other aggregates that was mined out of the ground. Just a quick little example how we use rocks. As well as rocks are a component of how we make soil. So even the soil that we depend on for all of our food that we grow is formed by, the alteration of rocks. So even going back a picture, even the soil that these plants are potted in, are due in part to rocks. So how is that the case? So initially you have some parent material. That's the original rock face, all right? Through processes like weathering and erosion, rocks can crack and they begin to break down. So rocks begin to crack. You might get organic material like moss or lichen starting to form on or in the cracks. Over time, due to the organic processes and rain from above, the rock material continues to break down. The plants or moss or lichens, some dies and then some grows back. So now you have organic or like say leaves falling onto the surface. So you have now organic material mixing in with broken rocks, and as those rocks break down, because remember, rocks are usually two or more minerals, so now you have minerals, you have organic material, and this is all the beginnings of a good soil. So over time, as that rock material continues to break down into different minerals, and organic material continues to kind of mix in with that broken down rock material, you continue to make soil, and then after time, you actually get different layers of soil. And again, so soil is mostly organic material, dead organic material, broken down rock and minerals, mixed with a number of other things, gases from the atmosphere. So that's what makes up soil. That's what makes up soil. Dirt is a little bit different. Dirt is just broken up rocks and minerals. That's what dirt is. To be soil, to actually have things grow in it, you also have to have organic matter that's kind of mixed in with that. Rocks and minerals are not organic. Those are inorganic substances. That meaning they don't come from living processes. Rocks aren't created by any living processes. Rocks are not alive. Right? Rocks are not alive. So dirt is just broken down rocks and minerals. Soil is broken down rocks and minerals mixed with organic material and some other things. That's the difference between dirt and soil. So even soil, it depends on rocks at some point to break down to get the minerals out, because you need good minerals to help feed the plants. So very important. So overall, minerals and rocks have usage. It's not just a science aspect of it. I like this little graphic, and it's going to be the last one for this section. But it's kind of cool that every American born as of right now, and this changes every year, so this is as of 2022. Every American born as of this past year, or starting this year, will need over 3 million pounds of minerals, metals, and fuels in their lifetime. Everything that we use, that we need, that we have, that we throw away, that we buy again, if you add all that up, 3 million pounds of stuff need to be ripped from the ground. For each person, for each American. We use a lot, we waste a lot. So, for instance, bauxite is a mineral, and that's how we get aluminum out. We extract aluminum from bauxite. So we need 1,800 pounds of bauxite, 55,000 pounds of cement, all the clays and coal that goes into electricity generation and other things that we utilize, copper that goes into all the electronics and wiring from everything that we have. Gold, you might not have any gold, but your electronics probably do. Small amounts of gold. Your computer definitely has some gold in there. Iron ore, it's how we extract iron. Between iron and coal and a few other minerals, you mix all that together. That's how we make steel, cars, and etc. Lead, lithium in batteries. Salt, not only for just eating, but a number of other processes. They're using water softeners. Maybe you have a pool and use chlorine. Derivations of salt are used in that. So yeah, almost 28,000 pounds of salt. I hope we wouldn't eat that much. Silver, again, using electronics. Over 1 million pounds of stone, sand, and gravel. Think everything that goes into building your house. And plus 1 million pounds of other stuff. So kind of cool. All right. Let's pause there. When we come back, we're going to just talk a little bit about the small stuff. What makes up minerals. We'll talk about atoms and elements and molecules and compounds very briefly. This isn't a chemistry class, so we'll just kind of touch on these things just a little bit, just to set a foundation, and then we'll move on. I'll see you back here in just a second. Bye-bye.